Alright, today we're going to look at how to solve quadratic equations using the quadratic formula. The quadratic formula, so far we've learned a couple of ways. We know how to solve quadratic equations by factoring and using the zero product property. We also know how to solve quadratic equations by completing the square. The last way that you can solve quadratic equations is by using the quadratic formula. And the quadratic formula can be used on any problem. Unlike factoring, which can only be used on some problems, the quadratic formula can be used on any problem. As long as the equation is in the proper form, which is standard form, as long as it's in ax squared plus bx plus c is equal to 0, then we can use the quadratic formula. This says where a is not equal to a negative number. A can be negative. I'm not sure why that's here, but a can be negative. Our formula is x equal to, so the solution is negative b plus or minus the square root of b squared minus 4 times a times c, and that whole thing divided by 2 times a. Alright, so if we can identify a, b, and c, we can use this quadratic formula to find our solutions. Now you'll notice this part under the square root symbol, the b squared minus 4ac. Alright, this actually tells us something important, because if you think about taking the square root of whatever this number is, if you take the square root of this number and this number b squared minus 4ac, whatever that is, if you take the square root of it and that's a negative number, well then you end up with imaginary number. And if you take the square root of this and the number underneath is 0, well then you only end up with one solution. So that is called the discriminant. That b squared minus 4ac is called the discriminant. The reason that it's important is because it tells us how many solutions we have. B squared minus 4ac. If that b squared minus 4ac, that value that's underneath the square root symbol, is positive, then we have two real solutions. That should make sense, because when you take the square root of that and it's positive, then it's a real number. And if that b squared minus 4ac, if that value is negative, then you have two complex solutions. And that should make sense, because if it's negative, then it's going to be imaginary, which means our solutions would be complex, both a real part and an imaginary part. So that's called the discriminant. That can help us determine what types of solutions we have. Let's look at how to use the quadratic formula. So number 1, x squared plus 7x plus 5. This is in standard form. It's equal to 0. Our a is 1. Our b is 7. Our c is 5. So I'm going to use the quadratic formula to figure out what the solution is to this equation. So x is equal to negative b. B is 7, so negative 7 plus or minus the square root of b squared, so 7 squared, minus 4 times a, which is 1, times c, which is 5, and all of this is over 2 times a, and a is 1, so 2 times 1. Alright, so if I can simplify this mess here, then I can figure out what the solution is. And this should simplify to either a real number or a complex number, depending on whatever this is under the radical. Alright, so that just becomes negative 7 plus or minus the square root. 7 squared is 49, and then negative 4 times 1 times 5, because they're all next to each other, they're multiplied, so negative 4 times 1 times 5 is negative 20. And this is all over 2 times 1, which is just 2. All right, well, this can simplify more because I know that 49 minus 20 is 29 as over 2. All right, so at this point, this can't really be simplified anymore. This would be an acceptable, you have a choice here. You can leave it like this or you can simplify it a little bit more. In some problems, you will have to go a little bit further than this, so I'm going to go ahead and do that in this problem. And the one step further you're going to have to take is to distribute the division to each of these. So instead of it being all over 2, we are instead going to put each one of them over 2. So it's going to be negative 7 over 2 plus or minus the square root of 29 over 2. Now, in this problem, this form is acceptable. This form would be acceptable in this problem. But it's good habit to go a little bit further to get to this form, because a lot of problems are going to require you to get into this form. Because if this were a complex number, you would have to split it up. So this form that I've circled is acceptable. You should know how to get into this form, though, by distributing the division, the over 2, to each part, to the first part and to the second part. All right, so that's the solution. So remember, that represents, this represents 2 solutions. It represents negative 7 plus the square root of 29 over 2, and it represents negative 7 minus the square root of 29 over 2. Okay, so keep that in mind. This plus or minus symbol right here, this plus or minus symbol means that we have 2 solutions. All right, one where square root of 29 is added and one where square root of 29 is subtracted. All right, so those would be acceptable solutions. Let's take a look at number 2. Number 2, x squared plus 6x equals 16. First of all, it needs to be equal to 0, so it's not in the appropriate form. So the first thing we need to do is move the 16 to the left side by subtracting it, which gives us x squared plus 6x minus 16 equals 0. Now it's in the proper form, and now I can use the quadratic formula. So a is 1, because of the 1 here, b is 6, and c is negative 16. So I'm going to substitute those values into my formula. X is equal to negative b, so negative 6, plus minus the square root of b squared, so 6 squared, minus 4 times a, which is 1, times c, which is negative 16, and this is all over 2 times a, and a is 1, so 2 times 1. All right, let's simplify this a little bit. So negative 6, that's just negative 6, plus minus square root, b squared, so 6 squared, that's 36, negative 4 times 1 times negative 16. So that's going to be a positive number, but let's see exactly what it is. So negative 4 times 1 times 16 is 64. So this is plus 64. And then this is all over 2 times 1, which is 2. Okay, well now we can simplify what's under this radical, because that becomes plus minus the square root. 36 plus 64, that's 100 over 2. All right, well you can see here that we actually are going to have to simplify what's under the radical, because that can be simplified. The square root of 100 can be simplified. Square root of 29 in the previous problem could not be simplified, but this one can. So if I simplify this, I get, let me cross this out, I get negative 6 plus or minus the square root of 100, which is 10 over 2. Alright, this represents two solutions. It represents negative 6 plus 10 over 2, and it represents negative 6 minus 10 over 2. Well, negative 6 plus 10 is just 4. And 4 over 2, 4 divided by 2 is just 2. So this one simplifies to just 2. The other one, negative 6 minus 10, is negative 16. And negative 16 divided by 2 is negative 8. So our other solution is negative 8. So this one could be simplified a lot. Okay, as long as we have numbers that can be combined, we can keep going. And this one allowed us to combine quite a bit to get two solutions, which were 2 and negative 8. What this tells us is that this one could have been factored. All right, since my solutions are whole numbers here, that does make a pretty strong argument that these could have been factored. And if we go back to the original problem, x squared plus 6x minus 16, we could have factored this and solved it instead of using the quadratic formula. All right, a times c in the top, b in the bottom. The two numbers that multiply to negative 16 and add to 6 are 8 and negative 2. So my factored form would have been x plus 8, x minus 2, which means my solutions are negative 8 and 2. All right, so if you had realized that this one could have been factored instead of using the quadratic formula, you probably could have done this problem a lot faster. But we don't always know that, and the quadratic formula is a good way to find the solutions if you don't know which method to use. Just use the quadratic formula and you'll find the solutions. Alright, so this is day 1 for the homework. It's going to be on page 56, two problems, number 4 and number 7.